Almost every industrial process consists of a repeating sequence or a series of subsequences. Before electronic control systems, these processes were often controlled mechanically, using rotating cylinders fitted with cams or pegs that actuated limit switches at precise points in time. These devices were known as drum sequencers or cam timers. For decades, they handled much of the heavy lifting in industrial automation. Their operation was simple but effective. As the drum rotated at a fixed speed, its physical features triggered switches in a specific order, turning outputs on and off without electronics or software. This allowed machines reliably to perform complex, timed operations. Drum sequencers were widely used in applications such as textile machinery, packaging lines, and automated assembly systems. You can still find similar mechanisms in old-fashioned music boxes, and cam timers are still occasionally seen in appliances like washing machines and dishwashers. But in most industrial settings, their use has largely disappeared. While these devices were rugged and repeatable, they had a major drawback: inflexibility. Changing a sequence meant physically modifying the hardware by moving cams, repositioning pegs, or replacing the drum entirely. Adapting a machine for new products or processes could be slow and expensive. With the rise of electronic control systems and eventually programmable logic controllers, PLCs, mechanical sequencing gave way to software-based control. The idea of sequencing didn't go away, but its implementation evolved from rotating steel cylinders to lines of ladder logic. So there is a trade-off. PLCs are incredibly flexible, but reproducing a simple mechanical sequence often requires a lot of ladder logic. It would be ideal to combine the conceptual simplicity of a drum sequencer with the flexibility of a PLC. That's exactly what Automation Direct's productivity PLCs provide through the built-in drum and sequence instructions. The drum, or DRM instruction, is the closest software analog to a mechanical drum sequencer. Instead of a rotating cylinder, it uses a step index that advances through a defined number of positions. Each position corresponds to a row in a drum table, where 16 output states are pre-configured. As the drum advances, based on time, events, or conditions, the instruction automatically updates the outputs for the current step. Functionally, the PLC is turning a virtual drum. Operation is straightforward. The enable input is level-driven. When it's on, the instruction solves every scan. Turn it off, and the instruction pauses while the current step's outputs remain active. The jog input advances the drum one step at a time, and reset returns the sequence to step 1, taking priority over all other input rungs of instruction. Each step can advance based on a duration, an event, or a combination of both. Optional tags let you monitor or even modify the current step number and elapsed time, and a done bit signals completion of the cycle. When the final step completes, the done bit is set, and the drum instruction waits to be reset or re-enabled depending on the configuration. Drum is ideal for linear, time-driven processes like wash cycles, indexing conveyors, or repetitive machine motions. The sequence, or SEQ instruction, takes a different approach. Instead of focusing on drum-style timing, it emphasizes process flow and step-to-step logic. Each step represents a defined state in the sequence, and transitions occur based on explicit conditions. Where drum mirrors the physical feel of a mechanical drum, sequence behaves more like a compact state machine. The rest of the program can simply ask, what step are we in? Outputs, timers, and interlocks are then tied to that step number, keeping ladder logic clean and readable. The sequence instruction supports up to 200 steps, with each step defining the state of up to 16 outputs, discrete and numeric. Enable starts the sequence, reset returns it to step 1, and a tag to control the current step number allows manual advancement or reversing. A done bit signals when the sequence completes. Together, DRM and SEQ offer two complementary tools, one that preserves the simplicity of mechanical sequencing, and another that extends sequencing into more adaptive, logic-driven control, all without the complexity of traditional step-sequence ladder logic. To learn more about these and all other instructions available in Productivity Suite, or about any of our other PLC lines, visit www.AutomationDirect.com. To see more productivity videos, click here. To explore the entire Productivity PLC line, click here. Click here to subscribe to our YouTube channel and keep up to date on all new videos and products at AutomationDirect.com.